People are now thinking seriously about putting data centers in space. One advantage of this is that there's lots of solar power in space, but one big disadvantage of this is that it's actually quite hard to cool down your data center. On Earth you can use conduction, convection, evaporative cooling, but in space you've only got radiation. You can only radiate your heat away. The formula for how much power is radiated is this. So the power radiated is equal to the area times a constant times the temperature in Kelvin to the power 4. So you're 16 times better at radiating at 700 Kelvin than at 350 Kelvin. If you just take the solar power, pump it through your GPUs, and then get that into cooling fluid, and then put the cooling fluid into a radiator, it turns out you need about the same area of radiator as you have solar panels. And so that'll end up being a significant chunk of the cost of this data center. But I was always wondering, can you shrink the radiators by using a heat pump to increase the temperature of the radiators? The idea basically works the same as your fridge. You take the heat from the data center and you use a heat pump to move the heat from the relatively cold GPU cooling fluid to the hotter coolant in the radiators. So then the radiators can be hotter, so in this example 700 Kelvin rather than 350 Kelvin. That would make your radiators 1/16th of the size, which sounds like a big win. The flaw in this logic is that heat pumps require energy. For a 2-to-1 temperature difference, they need the same amount of energy at least to run themselves as they pump. So if they pump 1 unit of energy, they take another unit of energy to run them. So I've included here the logic based on, this is an entropy consideration. You can't pump heat from a low temperature to a high temperature without giving something up. So then you've got several problems. So firstly, the radiator needs to eventually radiate away the power used in the heat pump as well. So they're now only 1/8 of the original size, not 1/16th. But a bigger problem is that you need twice as much solar power. If the heat pump is not as efficient as theoretically possible, then the radiators and solar power will be larger still. So you've gained on the radiator is indeed quite a lot smaller, but now you've got twice as much solar power needed. So depending on the economics of this, it might be the radiators are heavier than solar power panels, or it might be that solar panels are more expensive. So the exact details of whether this would work will depend on the engineering. But you absolutely can't just completely solve this problem using heat pumps. You're always going to end up with quite large radiators still required.